Hey everyone, Mrs. Rogstad here. I have another video for you today. We are talking about metric prefixes. So we've already learned about some of the different units of measurement that we can use to measure length or distance, that we can use to measure volume, temperature, mass, and so on and so forth. And we're going to do a deep dive into the metric system today. And what's really cool about the metric system is that it's very easy to convert because everything is based on powers of 10. So at the end of the day, you're really just moving decimal points around. So our objectives for today's lesson are number one, to become familiar with the metric prefixes and what they mean in terms of powers of 10. And then you should be able to convert from one metric unit to another using what's called the linear method that I will teach you. So here is the basic idea, and this is a chart that you're going to become very familiar with, and let's just dive right in. So these are the metric prefixes that I need you to know. So let's start in the middle. The base unit is going to be something like, it has to be a metric unit first of all. It might be grams, and grams have an abbreviation of lowercase g. It might be meters, and this will have an abbreviation of lowercase m. It might be liters, and that would have an abbreviation of uppercase L, and it might be seconds. So these are the major base units that we'll be using, and the cool thing is that any one of these prefixes can go with any one of these base units, and it works the same way. It's just that you would have a different base unit. So if you're measuring a mass, you'd use grams. If you're measuring a length, you'd use meters. If you're measuring a volume or how much space something takes up, you would use liters with an L. And if you're measuring time, then you'd do seconds. So what these prefixes do is change the quantity that you have or change the amount. So let's say seconds. A second lasts as long as this time, 1 Mississippi. But let's say you're measuring seconds that are much smaller, like the blink of an eye happens really fast. See if I can try it there. So a blink of an eye might be measured in milliseconds. And a millisecond is 1,000 times smaller than a second, meaning there's 1,000 seconds or 1,000 milliseconds in 1 second. Okay, so that's the basic idea of this. Now, these are all the different prefixes, and I've given you the name of the prefix, its abbreviation, and the abbreviation, the capitalization really matters. You'll notice that there are several M's here. Lots of M's. Okay, so let's just do a quick little primer on how to tell the M's apart. Okay, so when we have metric units, say milliseconds, the second letter is always the base unit. And the first letter is always the prefix. So if you have an M that's just by itself, or that is in the position of the base unit, you know you're talking about meters, because meters can only be a base unit. So you either have the base unit by itself or in this position, the second letter. So for example, we could put any of these prefixes in front of meters. We could have centimeters, we could have decimeters, we could have kilometers or kilometers, we could have megameters, we could have micrometers. These are all forms of meters, and putting these letters in front would change the value of that quantity. Okay, back to the M's. Capital M stands for mega. Mega means 1,000,000 times bigger. So a megameter is a very long distance. We're probably talking about here to Arizona or something. Okay, millimeter means 1,000 times smaller. So if you were to see mm, this is going to mean millimeter. So the prefix always comes first, and then the base unit. And then last but not least, because we have so many prefixes that start with M, we ran out of letters in the English alphabet, so we borrowed the Greek letter for M, which is mu. We pronounce it mu. And it basically looks like an M and a U put together. So you can write it like that with a nice little tail, and then it kind of looks like a U. Okay, so that's how we deal with the M's. Now let's look at the table as a whole. So over on this side, we're going to be dealing with bigger units. So these prefixes make it bigger. These prefixes over here are smaller. So a microgram is very, very tiny. And because these are smaller, I put the quantities as decimals. But I like to think of it of how many times smaller. Okay, so these are bigger numbers, but they're telling you how many times smaller. So, for example, there are 10 decimeters in 1 meter. There are 100 centimeters in 1 meter. Or you could say that 0.01 of a meter equals a centimeter. Okay, so that's how that works. Over here, this is just what each of the prefixes mean. And then these are exponents. Now, I'm expecting some of you may have seen these exponents before and some of you may not have, depending on how much math you've had. So don't worry about it if you don't know what the exponents are. Okay, that says exponents. Basically, this is counting how many zeros there are. So like for in a million, there are 6 zeros. So I put the number 6 there. It can also mean 10 to the power of 6, like that. And over here, there are 5 zeros. Over here, there are 4 zeros. 1,000 has 3 zeros. 100 has 2 zeros. 10 has 1 zero. And then the negative exponents mean we're moving the decimal point that many places. So we can move it 1 time, 2 times, 1, 2, 3 times, and so on. Okay, so I think I have everything here. Let's try to do some conversions with this. Oh, last but not least, I forgot the most fun part. There's a fun little cute acronym that we can use to remember how this goes, and that is King Henry died by drinking chocolate milk. Okay, so this acronym can help you remember at least the middle parts of the prefixes. So K, king, is for kilo. So King Henry died by for the base, drinking chocolate milk. This doesn't include the micro and the mega, but we do use the micro and the mega. You'll also notice that there are blank spaces here, and that means that these powers of 10 do not have prefixes, because once you get to a certain level, it doesn't make sense to do a prefix every power of 10. When you get out far enough, you do it every power of 1,000. So that's why we skip 2, and then we go on to the next one. All right, and maybe you can come up with your own fun little acronym. I've had students make up acronyms about kangaroos and stuff like that. Okay, so we're going to try some examples. I'm going to move myself over here, and let's see if we can do some conversions. So the basic idea is that I'm going to start with a quantity that I'm given, and in this case, it's 100 centimeters. And so what I'm going to do is then put my pencil on centimeters on my chart. Okay, now the base unit is meters. I don't have to worry about meters. That's just the base unit. It's kind of along for the ride. What I do worry about is the prefix, and the prefix is centi. And then this is where I'm going to, over here. I'm going to meters. So I'm going to put my pencil on the centi, and I'm going to travel to meters, which is the base unit. And that takes me 1, 2 places to the left. So I'm literally starting here, and I'm following the path until I hit the base unit. And because I went 1, 2 places to the left, that's exactly what I'm going to do with the decimal point. Now, if there's no decimal point here, you assume that it's right at the end of the number. And I'm going to do the same thing with the decimal point that I did in the chart up here. So because I went 1, 2 to the left, I'm going to move this decimal point 1, 2 places to the left, and then it's going to live over here. So that means 100 centimeters equals 1 meter, or 1.00, same thing. Let's try another example. So over here, again, my base unit is meters. I'm not going to worry about meters too much. It's just the base unit. And my prefix, I'm going from milli, which is lowercase m, to centi. So I'm going to put my pencil on milli. Maybe I should use a different color for this one so we can keep it straight. How about purple? Okay, so I'm going from milli to centi, and I'm going to start at milli, and then I'm going to go to centi, which I moved one place to the left. Okay, and because I went one place to the left, I'm going to take this decimal point and go one place to the left. So 10 millimeters equals 1 centimeter. All right, let's try another one. We might be moving a different direction this time. So again, I gave you one with a base unit of meters. It could be something else next time, but it's still meters. And let's change colors so I don't get confused. How about this off red? And this time I'm going from kilo, which is K, to the base unit, which is meters. So I'm going to put my pencil on the K, and then I'm going to move until I get to meters. So I'm starting here, and I'm going to go 1, 2, 3 places to the right this time. So that's what I'm going to do with this decimal point. I'm going to go 1, 2, 3 places to the right. Now, the question is, well, what do I do? I moved the decimal point over, but there's no numbers there. So if there's no numbers there, we add zeros. Okay, so let me rewrite this over here so nothing's in the way. Okay, so there's a 5. I assume the decimal point is right here, and I'm going to move it 1, 2, 3 to the right. And in each of these little U's here, I'm going to place a 0, and that's what you do to hold the place. So 5 kilometers equals 5,000 meters. Here's a couple more examples. So we have, now I'm switching up the base unit on you guys. 0.957 liters, which is a base unit, equals however many milliliters. So I'm going to go from base unit to milli. So I'm going to start at the base unit. I'm going to go 1, 2, 3 to the right. And that's what I'm going to do with the decimal point. I'm going to do 1, 2, 3 to the right. So that means that 0.957 liters equals 957 milliliters. So this can work if you, no matter what the number is on the left, you have to keep all the digits that are there. If you need extra digits, you add zeros, and that's pretty much all there is to it. So let's try one where we have mega or micro going on. And I'm going to change the color. How about this nice teal blue? Okay, so here the prefix is mega because it's capital M. My base unit is grams. Notice when you convert, you have to keep the same base unit every time. I can't go from megagrams to milliliters because I can't convert a gram to a liter. That doesn't make any sense because grams measure mass and liters measure volume. So when we're doing these conversions, we have to keep the same base unit. And we're only changing up the prefixes. So here I'm going from one kind of gram to another kind of gram. So it's all mass, so it's all good. I'm going from mega to kilo. So I'm starting at mega, 1, 2, 3 to the right. So I'm going to take this decimal point and go 1, 2, 3 to the right. And that gives us 659.3 kilograms. Now, looking at this, it kind of makes sense because a megagram is a very big unit. So if I have like less than 1 megagram, I would expect there to be more kilograms, and these quantities are equal to each other. I'm not changing the measurement. I'm just changing the units that I'm measuring it in. I'm changing into equivalent measurements. Okay, and now let's go, last but not least, change my color. We're going to go from milligrams to megagrams. This is going to be a big jump. So I'm going to start here, milligrams, and all the way to megagrams. So 1, 2, let's see if this will work, 3, 4, 5, 6, 7, 8, 9. Okay, so I have to go 9 spaces. You do have to count these blanks. So I move 9 spaces to the left. And that's what I'm going to need to do with this decimal point right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So notice I have these blank spaces here, and I'm going to have to put zeros in there. A 0 for every U that I make. So my answer over here is 0.000057398. All right, so in class you're going to have some practice work to do, and let me know if you have any questions. Have a great day.